Welcome to Tech Brothers. In this video, we're going to learn how to configure SQL Server High Availability groups in Linux CentOS 7. In this video, we'll be using Pacemaker as our clustering agent. In Windows, we were using Windows clustering services to accomplish the same thing. These are the steps. First, we will download and install the High Availability SQL Server High Availability package, and then we will enable both nodes that's going to be part of the cluster, and enable SQL Server High Availability on both nodes. Once that's done, we will create AG group endpoints and certificate. This is a bit different than Windows. In my experience, if the communication is open between the Windows nodes, then we don't need to set up the certificate if we have the communication internal between the nodes. But in Linux and Pacemaker, you have to create the certificate of each node, and all the nodes that is going to be part of your cluster of this AG cluster, you need to create the certificate and copy the certificate in each node. So for example, I have two nodes, so I will create a certificate of node 1 and node 2 and copy from node 2 to node 1 and vice versa. So the certificate will be copied, and then we will restore those certificates. That's how the authentication is going to work. If we don't do that, our authentication will not work. We still be able to create the high availability AG groups, but the failover will not happen. So then what we're going to do is create the endpoints. Endpoint basically is the communication link between the nodes and Pacemaker. So we have to create an account, SQL Server authenticated account, and then we need to give permission to that account that, okay, go ahead and connect permission to the endpoints, and that's how it'll communicate to each other. And then we'll create AG group using SQL Server Management Studio. Only difference is that we will be using external as a cluster type when we create the SQL Server AG group using SQL Server Management Studio. And then we will create SQL Server login and permissions for the Pacemaker. This is in case when failover happens, Pacemaker needs to have connect permission, server permission to the SQL servers in order to failover. We will create the IP address for listener, and we will also create availability group resource in Pacemaker, and then we'll create the listener using the same IP that we just created for in the Pacemaker. And then we'll test our failover. So these are high-level steps. I have written the other steps detailed that we will run on. Most of the steps are going to run on both nodes. So let's minimize this. So I have TBS node 1. This is and TBS node 2. These are the two nodes that's going to be part of AG cluster. These are the steps. We will be installing the steps on both nodes one by one. So our first step is install the SQL Server High Availability mysql-server-ha. That's High Availability package. So we'll install on both nodes. All right, the installation is finished. Our next step is enable always on availability groups. This is just like in Windows, we need to enable SQL Server for high availability. So this is the command to use. And we'll restart services, SQL Server services after that on both nodes. And now we need to connect to our SQL Server Management Studio in order to create the certificate and move those certificates into the file. So this is the command that we need to use. Let's copy this command. And we'll open the SQL Server Management Studio. It is open. As you can see that our SQL Server is configured with the using the Active Directory as well. Right here, TechBrothers /MSQL is connected. Let's refresh it. Okay, we're connected here using Windows authentication, but for this demo, let's use the SQL Server authentication. I'm gonna close this. This is I've connected with SQL Server using SA and TBS Linux Node 2 as well using SA. So let's finish the Node 1 first. We'll create the certificate. In my case, the encryption password is pass at 123, and create the certificate, name of the certificate right here, and the subject of the certificate. And then we'll back that certificate up in this location on our TBS Linux Node 1. So let's run this command. Command ran successfully. You can verify if this file exists. So let's quickly verify that if the certificate is backed up in that location. All right, as you can see, this file exists here. Let's do the same thing on Node 2. And for Node 2, we have certificate right here. Sorry. Connect with Node 2, open new query. All right, command completed successfully. Let's go back to Node 1 and create our endpoints. My endpoint name is TechBrothersIT AG. Listener port is 5022 in case you have to open it in your firewall. Right now my firewall is disabled, so I'm not worried about it. But if you wanted to turn this to production, then you need to turn on the firewall and open this port. And this is the certificate we just created. So execute this command. And now we'll do the same thing on Node 2. Create the endpoint. My connection is a little bit slow for some reason. The difference is that we are creating the endpoints using the certificate of each node. So I ran it on Node 2, so that is the certificate I use for authentication right here. Let's see our next step. Now we need to copy the node, the certificate from one node to another. Keep in mind, we just created the certificates on each node and they are placed in their respective node, but we need to copy, for example, Node 2 certificate into Node 1 and Node 1 certificate into Node 2. So we'll run this command on our Linux. So let's connect with the Node 1. Just say yes, I'm using SCP. Okay, this is completed. Now on Node 2, we'll move the certificate of node 2 into node 1. All right, that certificate is completed. If we go back to see that if both certificates are there in the location right here, let me see. Check my current directory. All right, as you can see, both certificates are copied. This is the certificate of node 1. This is the certificate of node 2. And same here. Both files are there. Now we need to give permission to MS SQL. That's the service account that the SQL Server is running under. So we need to give ownership of both certificates to the SQL Server. So you can run the command on both nodes. All right. One. I need to put CER there. I forgot to do that. So let me run this command first. And then this command. Basically, we're giving ownership to MS SQL on both of these certificates. Same thing will run on node 2. All right, now we need to create an instance level user. In my case, it's going to be TBS AG user using SQL Server Management Studio. And then we need to set up the permission, restore the certificate using that user. So I'll go and create user in both nodes, both SQL Server. Let me make sure that it's the same spelling. I'll just copy it. And I'm going to give sysadmin just to make it easier for this installation. It doesn't need sysadmin. All right, our user is created. Let's see our next step. we're going to restore the certificate on each node. So log into TBS Linux node 1 and run this command. Keep in mind we already copied node 2 certificate in node 1. So this is node 2. Let's go on node 1 and run this command. We're creating cert, TBS node 2, cert, authorization TBS. We're giving authorization to this newly created user. And from a file, this certificate file, we already made sure that that's there. So let's go ahead and execute this. Let me go ahead and make sure that the account is created. TBS AG user, TBS AG user. All right, it was complaining about TBS user doesn't exist. I did create the login. However, I had to run this command, create user TBS user for login to map the user with the newly created login. So that's how I did it. And when I ran this command, it was successful. So we're going to do the same thing on node 2. I'm going to connect with a new query. Paste this, and this is going to be node 1. That's cert, and we'll go ahead and use this. And let's run this command first before we run the command. Let me show you that it will give us error, perhaps, that cannot find the user. So let's run this command. And now if we run this command, then it should find the user. There you go. Let's take a look on our next step. So we have created the search that we copied. Now we need to grant permission right here. And do the same thing on node 1. That's completed. Now we're ready to create our availability group using SQL Server Management Studio with the external type. And then rest of the steps will complete right after we create the availability group using SQL Server Management Studio. So this is SQL Server Management Studio 2012. And it doesn't give you options since it's not SQL Server 2017. So I'm going to go and use into another server and use that server, SQL Server Management Studio, which is TBS. I don't have SQL Server Management Studio 2017 installed on this server, so I'm going to see that if I can pull SQL Server Management Studio on this server and connect with our Linux server. I'm going to run as administrator. Let's make it a little bigger. Maybe make it full screen. TBS Linux node 1. And we'll connect with node 2 as well. All right, let's create a high availability group. Right now, no high availability group. We have enabled in our previous steps node 1 and node 2 for high availability. So let's use the wizard. Here, the type needs to be external. So TBS test AG or Linux AG. We'll put it that way just so that we know that that availability group belongs to SQL Server that's installed in Linux. So next. And we have not prepared any database. All right, now the database is prepared. Let's go in previous and select next or refresh it. And as you can see, Linux test meets the requirement now. Select the database. And let's connect to replica 2. And we'll keep it synchronous. And these are the endpoints, as you can see, that we already configured. Listener, we're going to configure it later. And we're okay with this. These settings, click next. And we're going to do join only. That means we have already restored the database on node 2 in restoring mode, and it's going to just join. Click next, next, and finish. Let's look at the detail. All right, everything is completed successfully. Okay, and look at the replicas are connected. We have Linux test right now. No listener setup yet. We will do that in a little bit. Let's refresh this database and see it's synchronized. So now our availability is set up. However, the Pacemaker is still not configured to take care of this. So we are going to configure the Pacemaker the next. So let's take a look on our next steps. We have completed this step. So now to create a new login or use the same login to give Pacemaker permission and provide the view server permission, I'll give sysadmin to. As you can see that in this case, I am using TBS a user and I provided sysadmin permission, and I'm going to use the same user for Pacemaker. Put it in that Pacemaker, the file right here. We need to edit the file using Emacs right here, and then we will put the username and the password for Pacemaker to use. So let's go. So I'm going to copy this. Emacs is just a little utility that you can use. Okay, I don't have Emacs, so I'll just use VI editor. the editor right here. Save it. Same thing in here. And save this one too. And if you look at the contents, you'll see the user and the password for that user is there. Now let's go ahead and set up the permission. These are lots of steps, but I will paste these steps and you can modify based on your environment. That'll make it easier. Now we're ready to create AG resource in Pacemaker. Excuse me. So in my case, it's going to be TBS Linux AG right here. And since we have already created the AG, let's go ahead and get the name. Just needed to refresh. I'm hoping that I don't have to go to other server and just get the high availability here. Okay, there you go. TBS Linux AG. So that's our AG name. TBS Linux AG. So yeah, we will run this command. This is the existing AG group, and I'm creating right here the AG name, and resource name is going to be TBS Linux RG resource group. So I'll just go on node 1 and run this command. And let's look at the resources. So we have right here TBS Linux RG resources created. I'm ignoring this warning right here. It's being deprecated, so they don't want you to use -- master, but it took it anyway. So right here it's created. Now we will create listener IP and configure our listener, and then we will test our failover. So in my case, the listener name is going to be IP address. Resource name is going to be Linux SQL prod list, and this is going to be the IP address of the listener, which we will use when we configure that. Let's go ahead and configure the resource. Everything looks good. All right, let's go ahead and check the status again and see. We have 5 resources right here, and here is our listener right here. So now everything is done. Now let's go ahead and create our listener, and before we do that, we need to set up the constraint right here, that in what order the listener should come online. Constraint promote. This is our resource group, start the listener SQL prod list. Right here is our listener. So let's run this. All right, looks good. Now, whenever I need to create something new, I like to use the latest SQL Server Management Studio. So I will go ahead and refresh this and create a new listener. And we already have the listener name, the resource name that we used, Linux SQL prod list. Well, we can't use the entire name for 1433. I'll have to delete the resource and make it just exactly these many characters in the name. But let's go ahead and configure that because the IP address is available. We'll see that if it gives us hassle. So add the IP address, the same IP address that you configured there. So in my case, it's going to be IP4. Subnet mask 0. Click OK and click OK. Our listener is created. So let's go ahead and connect with our listener name. Keep in mind that it's not going to resolve the listener name right now. It will resolve by the IP address and the port, and then we will go in our DNS and create a name in order to resolve by name. So 168.1.104 and 1433. Let's see if we can connect, and we are connected. There you go. All right, our next step is to check our failover. You can see. Let's see if our failover works. So right now we have our primary is node 1. As you can see, let's refresh this. Our primary replica is node 1, secondary replica is node 2. So once we test our failover, this should become secondary and this should become primary. So quickest way to failover is I'm going to shut down the cluster services on node 1, so everything will move down to node 2. All right, we're stopping everything, stopping cluster services on node 1, and let's refresh our databases to see that what has happened to that. Now it's still in resolving, but it'll come online in a little bit. go ahead and connect with cancel this and refresh this one. As you can see that it has become secondary, however it has not connected yet. I'm not sure that what has happened, but I will find out and will share with you. Let's go ahead and try to connect with TBS Linux Node 1. Let's go ahead and start the services for the cluster and see if we can connect with the node 1 too. Check the PCS status right here. This is still starting state, so let's give it a little bit time and then we'll refresh it. All right. As you can see, now our node 1 is secondary and node 2 is. This is not really a good way to test the failover the way I did it, but I just wanted to make sure that you know, we do like hard shutdown and still see that if it changes that the node 2 becomes primary and node 2 becomes secondary. So this is it. I will actually make another video of a manual failover of SQL Server AG cluster, but keep in mind that if you right click on this, you don't get failover option right here using SQL Server Management Studio, so you have to failover from Linux side. And I hope this helps.